Morning, everyone. This is Mr. Tricino. I hope that you guys had a very safe Easter. I hope you enjoyed your spring vacation, spring break. Now, let's go over now to our very first online learning session. So today, people, we will be talking about counting. Yes, I know it seems weird to hear, but yes, we will definitely learn about counting today. But before that, let us go over the PGCPS guidelines on online safety, right, which is follows. So please be reminded that the PGCPS administrative procedures regarding appropriate use of technology, social media, and email continue to apply to our online instruction. In addition, this session may not be recorded without the instructor's consent. So this particular sentence that I highlighted, this is not definitely at par to what we have because this is a pre-recorded lesson. So we will construe that as this recorded session may not be shared without the instructor's consent. So if you would like to share it to somebody else, maybe help them understand counting, please let me know so that we would be able to help them. A description of the applicable procedures is provided online in the Student Rights and Responsibilities Handbook. Thank you for your cooperation. So if you would like to know more about the online procedures for safety, definitely do consult the Student Rights and Responsibilities Handbook. You can access that in the PGCPS portal. If not, I think I might have put up a link in the Google Classroom, so also check there. Okay, so now that that's out of the way, let's now proceed to our new lesson. Oops. Let's just, ooh. Okay. Ha. All right, I had to check it whether it was not missing anything. Anyways, this text we will be going over with is also posted in the Google Classroom. So just in case it's easier for you guys to just read it over instead of listening to my great voice, you are free to do so. All right, so now we're ready. We have the fundamental principle of counting. Yes, there is a fundamental principle for counting. So the techniques that we will be considering here, all right, will be the one for the multiplication and the division, multiplication and addition rule. Okay, so let's go. Lesson objectives. Aha. Right. So what are we? What's our goal for today's lesson? So it's to teach, clarify, and show techniques of effective counting. So counting might seem quite trivial because you might say, Mr. Tucino, counting is just like 1, 2, 3. However, more complicated situations require more complex methods of counting. Okay? Just to illustrate, consider the 3 situations below. First situation, how many 5-digit numbers are there? All right, which of course ranges from 10,000 to 99,999. Obviously, counting with your fingers will not be the best strategy in trying to answer this question. Second question, all right, much harder question. How many 5-digit numbers are there so it has non-repeating digits? So this time, not only are you counting 5-digit numbers, but you also need to exclude those which would have repeating digits. So some examples of valid numbers are like 12,345, 20,917. So what do I mean when I say non-repeating digits? What I mean is, if you use a particular number for a particular position, you do not use it again. In this case, for 12,345, 1 was used in the 10,000s place. It was not used again for any other position. The same with 2, 3, 4, and 5. You may interchange this set of numbers. For example, instead of starting with a 1, maybe you can switch the position of the 1 with the 5, and still it would be a valid number. It would still be one of those numbers that you need to count. Okay? So can you count that? A bit harder, huh? Now, letter C. This one has the Mr. Tricino stamp of approval. How many 5-digit numbers are there such that if it begins with an odd number, it should end with an even number and vice versa? So what does that mean? Okay, it's possible that the number starts with an odd number, but it has to end with an even number. Okay, so it starts with an odd. That means the first digit is an odd number. The last digit should be an even number. So in this case, 12,345 is not a valid number in letter C. It should not be counted. Vice versa. If it starts with an even number, it should end with an odd number. Thus, 20,917 is actually a valid number for letter C. That's good. Wait, there's more. And also containing non-repeating digits. Okay. Thus, so not only should you consider the number or the digit that it begins with and the digit that it ends with, it should also have non-repeating digits. So what do you think now? Is it still easy to count? Okay. Through this lesson, hopefully, you will garner an understanding of how to effectively count numbers in this particular situations. Now, counting is very, very important because counting allows you to figure out how many possible scenarios are there. If you are into computer programming, you need to identify what the possible scenarios are. Right? If you are in crisis management, you need to figure out how many possible, things should happen before a worst case scenario happens. So counting things is definitely a very, very important thing. And it's not just simple counting. Sometimes it's complicated counting. So hopefully, the lesson for today gives you a good idea of the algorithm necessary to be able to count effectively. Let's now go to the lesson. First, before we count, we need to make sure of two things, all right, which is about the exclusivity of events. So there's mutually exclusive events and there's non-mutually exclusive events. The difference is whether they can happen together or not. For mutually exclusive events, the two events cannot happen together. If one happens, the other is bound not to happen. For non-mutually exclusive events, if one event happens, the other can still happen. But in this case, in this particular context, this particular lesson, when we say non-mutually exclusive events, we mean that when one happens, the second event has to also happen, right? So the two events need to go together. But in general, when you say non-mutual exclusive, when one event happens, the other event can still happen. All right. Whereas mutually exclusive, when one event happens, that effectively prevents the other event from happening. Right? Okay. So let's try to see some different examples and determine or practice identification of whether the events are mutually exclusive or non-mutually exclusive. Okay. So here are the following events. Number one, sitting and standing on the same chair. Is that mutually exclusive or non-mutually exclusive? Number two, rainy and sunny day. Mutually exclusive or no? Passing and failing a quiz. Even so. Is that a mutually exclusive or a non-mutually exclusive event? Number four, graduating high school and going to college. Is that a mutually exclusive or a non-mutually exclusive event? All right. So if you need more time to figure out the answers for this, you may pause the video. All right. Think it out. Then once you have your answers, all right, you may unpause the video and wait for the big reveal of the answers. Okay, I will give you about 2 seconds to give you time to pause it. Then afterwards, I will reveal the answer. Okay? I think that should be enough time for you to have paused or unpaused the video. We'll now proceed with the solution. Okay. So number 1 and number 3, both are mutually exclusive events. Number 2 and 4 are non-mutually exclusive. So number 1, sitting and standing on the same chair. You cannot achieve this one. If you are sitting on a chair, then you cannot be standing there. Now, squatting is an altogether different thing. Okay, so squatting is neither sitting or standing. It's halfway between the two. So it's neither of the two. Passing and failing a quiz, I think this is pretty much an impossible thing to happen, right? You cannot pass and fail at the same time, right? You can pass, but then the teacher adjusts the passing grade and you fail. Or you could have failed, the teacher adjusts the passing grade and you could have passed. But it is neither both. It cannot happen together, that you simultaneously pass and fail the quiz at the same time. It has to be one or the other, which is, of course, a characteristic of mutual exclusivity. Number 2 and 4 definitely are non-mutually exclusive because the happening of one does not prevent the happening of the other. All right? So in this case, we're not going to go with the main context, but later when we start counting, that is when we start to really go over that non-mutually exclusive events means the events need to happen together. Okay. All right. So if you have any questions on those, definitely do put them up on the Google Docs that I will be attaching or that I'll be putting up along with the recording of this lesson. That way we can go over any questions you have. Okay, so moving on, non-mutually exclusive events. So as I mentioned earlier, in this context, we say that for non-mutually exclusive events, the happening of one should guarantee the happening of the other. All right, so if two events are definitely classified as non-mutually exclusive, then the number of ways that event A and, okay, take note, it's and, so it has to, together. Event A and event B, all right, can be counted by multiplying the number of ways event A and B can happen. All right, so if you would like to figure out how many ways can event A and event B happen together, you just have to multiply the number of ways event A happens with the number of ways event B happens. So in this particular context, N refers to particular symbol in sets. N just refers to the number of things. So N here refers to the number of ways A and B happens. It's N of A, which is number of ways A happens, times the number of ways B happens. So just multiply. So the next example will actually go over to the applications of this particular thinking. All right, so for number one, so Johnny is going to attend the party. So as he opens his closet, he notices that he has 10 shirts that he could possibly wear going to the party, and he also has 8 pairs of pants. Now we will assume that any combination of shirts and pairs of pants work so that he can actually choose any combination. Now the question is, given that these are his choices, how many possible shirts and pair of pants combinations can he actually choose from? So this one definitely, we're going to treat this as 2 events that has to happen together, because we cannot assume that Johnny can go to the party by only wearing a shirt. Johnny has to wear some pants as well. Or Johnny goes to the party wearing only pants, no shirt. All right. So the shirt and the pair of pants need to go together. Right? Though I'm not sure, whether, but let's not delve over that. Let's just go with number 2. Number 2, how many 2-digit numbers are made up of different digits? Oh, this question is very, very similar to that which was posted earlier. So if we can figure out how to answer number 2, definitely that helps us to answer one of the main questions. All right. So if you need some time to actually try and work this out by yourself, you may pause the video and then unpause it after. Right, I'll give you time to definitely pause. All right. Okay. So I hope you were able to pause then and unpause later. Now we go over with the solution and answer for each one. Okay, let's start with number 1. All right. So for number 1, all right, we need to know that Johnny's apparel consists of a shirt, which of course we'll say is event A, and a pair of pants, which of course we'll say as event B. Thus, the number of ways that Johnny can choose his apparel can be counted by number of shirts and pants. Remember, we are considering the situation where he goes to the party wearing both a shirt and a pair of pants, right? They have to go together, right? He cannot go to the party wearing only a shirt or wearing only pants. He has to wear both. Okay, so thus, the number of ways that he can choose whatever attire he would like to go to the party would be equal to the product of the number of shirts he can choose from with the number of pants he can also choose from. So according to the problem, Johnny has 10 shirts and also has 8 pairs of pants. So therefore, the number of apparel combinations Johnny has, which is made up of shirt and pair of pants, is 10 times 8, which is 80. All right. So that is how many apparel combinations you can actually go to the party. So now that we have number 1 done, we're now going to go over with number 2. Now number 2 is slightly harder than number 1. So what we're going to do is we're going to switch over to a particular whiteboard setting. Okay, and here we go. And then we will use this to actually discuss. All right, so number 1, we're looking for 2-digit numbers, which are non-repeating. All right, take note, non-repeating. right? But there's only two-digit numbers. Now, a two-digit number is made up simply of a tens digit and a units digit. Tens, all right, units. Okay, so the question is, okay, so if the number of tens digit is our event A, how many possible choices do we have for the tens digit? If the units digit is event B, how many possible choices do we have for the units digit? How many digits do we have all at all? So the digits that we have should range from 0 all the way to 9. So we have 0, 1, 2, 3, 4. Oops, that doesn't look 4. 5, 6, 7, 8, and 9. Okay. Thus, we actually have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 possible digits to choose from. Now, note that at the 10th digit, we cannot begin with a 0, right? We can't begin with a 0. Why? Because if we start with a 0, then that means it's actually a singular digit, like 09, 02. Isn't that like a singular digit? I mean, 20, that's the two-digit number. But then the 0 is more like at the units position, not at the tens position. So if 0 cannot be chosen as part of your tens digit, then that only gives you 9 possible digits to choose from in your tens digit. Aha! Okay, that's great. Now let's say I already chose a tens digit. Let's say I chose 3. Right? Okay. 30. All right. Okay, now take note, it has to be non-repeating. Okay, so now as I go to the units digit, I cannot choose 3 anymore. Okay, so how many digits can I choose from? Is there only 1, 2, 3, 4, 5, 6, 7, 8 digits to choose from? No, right? Because in the units digit, this time, you can actually choose 0. 0 can now be chosen. So therefore, the number of choices I have for the units digit would be 1, 2, 3, 4, 5, 6, 7, 8, 9. Also 9 digits because this time 0 is a part of the digits I can choose from. So therefore, if event A and event B needs to happen together, so therefore the total number of ways that event A and event B can happen is 9 times 9, which is 81. All right, so there should be 81 two-digit numbers which has non-repeated digits. Aha. Let's go over to the lecture and see whether this one is really true. Okay. Aha. All right. It is indeed 81. All right. Okay. Do we also have the 9 times 9 here, right? Okay, but might say, Mr. Josino, is there a way to actually check this? Actually, there is. All right. Actually, there is a way to check this. All right. Now, to be able to check this, we need to figure out how many two-digit numbers are there. That means from 10 all the way to 99. Now, using principle of counting, we need a tens digit and a units digit. So for the tens digit, we cannot begin with a 0. So we only have 9 choices for that. For the units digit, we can choose 0. So besides the 1 to 9, we also can choose 0. That gives us 10 possible choices for the units. So in that case, we have 90 two-digit numbers. All right. I mean, the digits can be repeated here, of course. It's a non-restrictive two-digit number. So if I ask you how many numbers are there from 10 to 99, that's 90 numbers, Mr. Trocino. Okay, so to be able to count how many are those which has non-repeating digits, we just need to take out the numbers which have repeated digits. In this case, there are only 9. What are they? We have 11, we have 22, we have 33, all the way to 99. Those are the only 2-digit numbers which have repeated digits. So from 11 going to 99, how many numbers are there? We have 11, 22, 33, 44, 55, 66, 77, 88, and 99. Only 9 numbers, which makes sense, of course. All right? So therefore, if we have 90 total 2-digit numbers, and then we subtract the 9 numbers which have repeated digits, right? Then we have 81 2-digit numbers which have non-repeating numbers, which makes sense. If you don't believe me, you are free to count. Of course, you are free to write down all 81 of those numbers. But of course, right, there is no need to check, as Mr. Tricino has already done the math and has already verified the answer. Okay, so if you have any questions on this one, as I mentioned earlier, you can write it on the Google Docs that I will be attaching here. Oh, by the way, the Google Docs would be our live chat discussion. So instead of using any other protocol to actually chat, we will be using Google Docs. That way, we can all participate in putting our answers, in putting our questions. We can interact, right? And if I do have to write in a handwritten solution, I could definitely take a screenshot of that handwritten solution and I can immediately attach it to the Google Docs so that everyone can actually peruse the answer. Now, the schedule that I will be live in our Google Docs, that means I will definitely be online to answer any questions, would be from 11 a.m. to 12 noon. That is during Monday, Tuesday, Thursday, and Friday. So on those 4 weekdays, I will definitely be online to answer your questions from 11 to 12. On Wednesday, because we actually have a math collaboration, I won't be able to log in until 12. So on Wednesday, I would still be online that day, of course, but it will be at a later time, which is 12 to 1. Okay, so remember the schedule. Of course, I'll be posting it in Google Classroom and of course in the Google Docs. All right, but don't worry. If you actually posted the question, let's say let's say this goes live on Tuesday and you posted the question like quite late. Let's say it was around 11:40 and there were a lot of questions already going on, so I don't have time to actually answer them. Then we will go revisit it the next day. So don't worry about it. We have like a week's worth of discussion to actually go over. Right now, the reason I'm actually putting them all together is so that everyone's questions can be addressed, because I know for a fact that some of you might ask a particular question which somebody is also thinking about. That way, when that question is asked, then it's easy enough. Okay, that was my question actually. So I'll just wait for Mr. Tricino to answer that question and it should be good. All right, so remember the schedule. Anyways, going back to the main lesson. So now that we've finished talking about non-mutual exclusive events, we now go to mutually exclusive events. Mutually exclusive events are events that cannot occur together. So the happening of one prevents the other one from happening. Right? So for mutually exclusive events, the number of ways that event A or event B happens can be counted by adding. So for non-mutually exclusive events, if the two events need to occur together, you have to multiply. But if the two events cannot happen together, then you need to add. Same terminology. N, number of ways A or B happens, is equal to number of ways A happen plus the number of ways B happens. Now take note, the interpretation of or in this context will be as an exclusive or. An exclusive or means that either A or B happens, but not both. As I mentioned, the happening of one prevents the other from happening. That is what we mean by an exclusive or. Because in the English language, or, although sometimes I do have my reservations that in English, when they mention or, what they usually mean is an exclusive or. However, sometimes it means at least one of the given scenarios. Okay, so let's now go over some particular examples and see how we apply this technique. Okay, so now we're back to Johnny. So this time, Johnny has already chosen the shirt and the pair of pants he would like to go to the party with. Okay, that's fine. Now, all he needs to do is choose the footwear. So he goes over to his shoe rack. As he goes over to his shoe rack, he sees that he has 5 sneakers and 3 slippers to choose from. Now, we will assume that any sneaker or slipper he chooses would definitely work well with whatever shirt and pants he's actually chosen already. Okay? So any of those sneakers and slippers would work well with his apparel. The question is, how many possible footwear can he choose from? Okay. Now, if you look closely, this number 1 definitely talks about mutual exclusivity. Why? Because if he decides to wear sneakers, then he cannot, of course, choose to wear slippers. As of course, we're going to assume that he is going to is going to go to the party with matched footwear. So if he chooses sneakers, he goes to the party with the same set of sneakers, right? Left and right. Okay, he does not choose like let's say sneaker A on the left and a sneaker B on the right. No, he goes with the correct pair. Also, we cannot say that he will go to the party wearing both a sneaker and a slipper. Right? I don't think, I don't understand how it's going to work. All right? But he will not go to the party wearing both. All right? Okay, so definitely, if he chooses to go to the party with a sneaker, definitely doesn't go there with a slipper. Okay. Next question, number 2. How many 2-digit numbers are there such that the 10th digit is less than the units digit? All right, now this one is quite difficult. All right, so we're looking for 2-digit numbers such that the 10th digit is less than the units digit. I think it's still countable. We can still count it manually, but we will try to come up with a particular method on how to do this more mechanically. Okay, so let's start with number 1. Okay, so for number 1, as I mentioned, this is an exclusive, these are mutually exclusive events. Choosing a sneakers definitely bars him from choosing a slipper. So therefore, the total number of ways that he can choose a footwear to go with the apparel he chose would just be 5 plus 3, just the sum of the 2 events. So 5 sneakers to choose from plus 3 slippers to choose from gives you 8 possible footwear to choose from. Right? So he only has 8 choices of footwear to choose from. Okay. Now, for number 2 is a bit more difficult. how many two-digit numbers are there such that the 10th digit is less than the 12th digit? So definitely, we consider the fact that the 10th digit has to be a smaller number. For example, 15. So 1 is smaller than 5. Okay? That would be an acceptable number to choose for number 2. So the question is, how many possible numbers are there? All right. So to do that, we're going to go over to our whiteboard and actually try to solve it. Now that we're here, okay, we're going to start off. Oops, I don't want to begin with the blue one. Let's go. So two-digit numbers. We have a tens digit, right? And we have a units digit. Okay, we know the tens digit must be smaller than the units digit. Okay, so how do we actually begin counting the number of numbers that actually satisfy this one? So to do this, we're going to break them down in terms of cases. All right. In counting, breaking a particular event in cases is quite helpful if you cannot approach the problem in general. You specify a particular condition and then you go with the next condition. First off, right? Case number 1. Oops, let's erase this. Let's make this case number 1. All right, oops. Okay, oops. Let me just erase the whole thing. Case 1. So for case 1, we're going to assume that the tens digit is 1 and we're just figuring out what the units digit are. Okay? I mean, what the units digit is. Remember, linking verbs are important. Now, if we start off with 1, how many possible units digit do we have? I mean, our digits ranges from 0 all the way to 9. But if we start off with 1, okay, we have only one choice here. How many possible choices do we have for the units digit? We cannot choose 0 because 0 is smaller than 1. We cannot choose 1 because 1 is the same as 1. So therefore, the first acceptable number here should be a 2, like 12. 12 would be an acceptable number. The units digit for 12 is higher than the tens digit. So 12 is good. So 12, 13, 14, and so on and so forth, all the way to 19. So it starts off from 2 all the way to 9. So from 2 to 9, that gives us about 8 possible combinations. 12, 13, 14, 15, and so on. So on and so forth. So therefore, if we start off with 1, we have 8 possible numbers that actually satisfy that case. Right? Now let's go to case 2. In case 2, we assume that the two-digit number begins with a 2. Right? Like 20, 21, and so on and so forth. Right? So again, for the tens digit, we are restricted to only one choice. We have to choose 2. All right? There's only one choice for the tens digit, which in this case is 2. However, the number of units digit is also restricted because we cannot choose 0, 1, nor 2. Therefore, the first acceptable digit that we can use is 3. So it's from 23 all the way to 29. Now, 23 all the way to 29 is actually 7 digits. 7 types of numbers. 23, 24, 25, 26, 27, 28, 29. So therefore, if it begins with 2 and satisfies this condition, you only have 7 possible numbers. Okay? If you continue this, if you continue determining all the cases here, you will actually see a particular pattern. Right? You will see 8, 7, 6, maybe 5, 4, 3, 2, 1. Let's try to write them down. So we have 8, 7, 6, 5, 4, 3, 2, and 1. Okay. When does the one case happen? The one case happens when the 10th digit is actually 8, because the only number that would satisfy, the only 2-digit number that would satisfy this condition is, that begins with an 8, is an 89. So you only have one possible number there. On case 8, which means it begins with an 8, it's only 89. Okay, so therefore, there's only one case there. Now, if it begins with a 1, it cannot begin with a 2. Similarly, it will not begin with a 3. Right? So therefore, these cases, all right, are exclusive of each other. If case 1 happens, then case 2 should not happen, nor should case 3 happen. So these 8 events being mutually exclusive with each other, that means the total number of ways that a 2-digit number, all right, will have its 10th digit smaller than a unit digit number is only, so 8 plus 7 plus 6 plus 5 plus 4 plus 3 plus 2 plus 1, it's only happening 1 out of 36 ways. Okay? So there are only 36 possible numbers that actually satisfy this condition. So let's try to see whether the template earlier would actually support our computations of 36. Okay. Aha! There we go. 36. All right. As I mentioned, the way the counting works is you count first the number of possible numbers that begins with 1, then the number of possible numbers that begin with a 2, and so on and so forth, all the way until it begins with an 8. Now remember, you cannot have that with a 9, because if a 10th digit is a 9, then there is no acceptable units digit, because every other digit is smaller than 9. Thus, the highest possible number you have that satisfies this condition was actually 89. Okay, and that, of course, gives us the total of 36. Now, we go back to our original question. Right, so this was posted earlier in our lesson objectives. So we are supposed to count how many possible numbers are in this particular cases. So I actually have answers for this one, but part of the work I'm going to be assigning for this week is, of course, for you guys to identify the reasoning behind the answers. So how many 5-digit numbers are there from 10,000 to 9,999? Okay, so according to my solution, according to my answer, there should be about 90,000. I even put up there 9 times 10 times 10 times 10 times 10. What is the significance of this particular solution? Why does it work like this? Why are those the numbers I chose? How many 5-digit numbers are there so that it has non-repeating digits? I have this one, 9 times 9 times 8 times 7 times 6, which eventually gives me this one. What's the significance of that? And then for letter C, how many 5-digit numbers are there such that if it begins with an odd number, it should end with an even number and vice versa? and also containing non-repeating digits. So I begin with this one, number of numbers that begins with an odd and ends with even, plus the number of numbers that begins with an even and ends with an odd. All right, I also have this. Why are those the numbers I chose? All right, so that would be part of the work. You will have to explain to me why those were the numbers I chose. Okay, understanding how the solution works is very important to being able to count very well. Okay, so I will also be putting this up in, I guess, Google Forms. So for the most part, the work I'll be assigning would be in Google Forms. I'll try maybe um, other media to actually gather work. But for now, most likely we'll be using Google Forms for graded work. Right. Anyways, that concludes our lesson for this week. So if you have any questions, do make sure that you actually put it up on our Google Docs. And if you have, by the way, I forgot. The deadline for the work is always 2 days after, which would be on Thursday. So if I post this on Tuesday, you have until Thursday to actually finish it. I'm trying to like keep it few so that it wouldn't be too difficult for you guys to finish. So I guess this is it for this week. All right. So stay safe. All right. And hopefully you learned something from our lesson for today. Bye. Stay safe again.